Hello, Mr. Dashel. How are you? Can you hear me?
Yes, sir.
Okay. So did you have Math Olympiad yesterday, Dashel? Did you already participate?
For Timo, yeah, for Timo was a while ago. Yeah, just this
It was
morning.
this morning.
Yes,
Oh, really? How many questions did you solve?
most of it.
Well, actually, how many questions were there in the contest?
Like 25.
25. And time? 90
Time
or
was, I'm pretty sure it was 90.
90? Okay. What is the name of the contest again?
Timo, sir.
EMO. EMO.
TIMO, sir.
EIMO. What is it? What is it? What does it stand for?
Thailand International Mathematical Olympiad.
Ah, Thailand. I see. Okay, very good. Very good. Mr. Franz, welcome. Good to see you again. So we are together again. Today is, I think, a last class about trigonometry. I mean, at least for now. Okay, hi, Franz. I see your message. And after that, hopefully we will see. Okay, I don't know. We are gonna. Am I gonna teach next week any other topic with you or with other students? Okay. So we have already did a few questions related to trigonometry. We are actually just using what is it, very basic definitions of trigonometry. And of course, trigonometry is very big topic. It is offered to students or taught to students in grades 8 and 9 and 10 and 11. And of course, the university, all math courses actually they involve trigonometry. Today, we'll just start with the easiest questions because we already had 3 classes regarding this topic. Actually, and also, as you know, each test, it has 4 different sections, section A, B, C, and additional questions. Section A, let's say they are warm-up questions. Section B, a little bit harder questions. Section C, the hardest one. Additional questions, also the most challenging questions related to this topic. And what is it? It's a kind of a revision test, okay? Because we have already studied and just doing some revision. And in this way, we will just conclude this class. All right. Yes, I will keep teaching, okay? So if you have any questions anytime, you can just stop. And if you want to say something, feel free. Because usually in learning, when it is interactive, you know, discussion based and not only teacher based, but teacher and student based, actually. You ask, I answer, I ask, you answer. And this way it's more fruitful, but maybe this online, a lot of students, they just prefer to be quiet. Okay, it's okay. So all right, in this question, given that square root of 2/2 is less than or equal to sine of theta, less than or equal to cosine of 20, and the angle theta is between 0 and 90 degrees. Find the range of values of theta. That means that we have to find the possible values of theta that satisfy these conditions, okay? So since in the given condition, we have sine of theta, on the right-hand side, we have cosine of theta, and theta is between 0 and 90. So we try to express everything in terms of one function. That is a kind of general rule in solving problems like this. So we know that actually this sine of 70 degrees, right, is equal to cosine of 20 degrees, or cosine of 20 equals sine of 70, because 70 and 20, they are complementary angles, right? When they are complementary angles, the sum is equal to 90. And we know the sine of alpha is equal to cosine of beta if alpha plus beta is 90 degrees. If I rewrite this inequalities again, here we have square root of 2/2 is less than or equal to, here we have sine of theta less than, what is it? Here we have sine of 70 degrees. So now we know the sine of function in the first quadrant, it is increasing function. Increasing means that if you just increase, it is this input variable, right? And also output variable will be bigger. So just consider in this case then, so this instead of this square root of 2 over 2, we can just write here sine of 45 degrees less than or equal to sine of theta less than sine of 70 degrees. So from here dot dot dot, actually the possible all the range of possible values of theta will be between 45 inclusive theta less than 70. Okay, if you just pick any angle between 45 and 70, it satisfies the given condition in the problem. Another example. Given that cosine of theta equals 9 over 41 and theta is between 0 and 90, find the value of theta. Okay, to answer this question, immediately we have to use our reference triangle, right? If you draw a right angle triangle, let's say this is our reference right angle triangle, and this is 90 degrees. And suppose that this angle is theta. And by definition, what is cosine of theta? Is defined as adjacent side over hypotenuse. So this one is adjacent side, and this one is hypotenuse. So cosine of theta is equal to 41. To find the sine of theta is opposite side over hypotenuse. So suppose that this side is x. Using Pythagorean theorem, we can determine the value of x. So here we have x squared plus 9 squared is equal to 41. So now from here, what is x squared? X squared equals 41. Here should be squared. 41 squared minus 9 squared. And that's equal to, what is it? A squared minus b squared. That's equal to a plus b times a minus b, or a minus b times a plus b. Now from here, what is 41 minus 9? That's equal to 32 times 41 plus 9. That's equal to 50. Or I can just write it as 50 is 2 times 25. 2 times 32 is 64 times 25. So now if you take square root of both sides, then x will be 8 times 5. That's equal to 40. So now from here, dot, 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 sine of theta is equal to opposite side, that is 40, over hypotenuse, that is 41. And because since theta is between 0 and 90, we have only one possible value. Okay. Next question. Question 3. Evaluate sine of 57 degrees times cosine of 33 and sine of 33 times cosine of 57. Now, if I try to express everything in terms of one function, what happens here? Here we have sine of 57. And how about cosine of 33? Cosine of 33 is sine of 57. And next one is, how about in terms of cosine? Sine of 33 equals cosine of 57. So here we have cosine of 57 degrees times cosine of 57 degrees. So sine 57 times sine 57, that is sine squared 57 degrees. And plus here we have cosine squared 57 degrees. That is sine squared of alpha plus cosine squared of alpha. That's just the first, but the most important identity in trigonometry. That's equal to 1, dot, dot, dot. So the answer of, the value of this expression is equal to 1. Okay, question 4, proof. It says prove the identity. proving the identity, right, using the left-hand side and a bunch of algebraic manipulations, we try to obtain the right-hand side of this identity. Or using, what is it, the same thing, and we have to show that, right, A will produce B, or B will produce A, if we are trying to prove that A is identically equal to B. So now let me just start from the left-hand side. Here, left-hand side of the equation is maybe LHS left-hand side. That is 1 over 1 plus tangent square root of theta, right? And if I just multiply numerator and denominator by cosine square root of theta, here we have cosine square root of theta, and 1 times cosine square root of theta, that is cosine square root of theta. And what is tangent square root of theta? That's equal to sine squared over cosine square root of theta. And if you multiply by cosine square root of theta, here we have sine square root of theta. And we have just proved that sine square root of theta and cosine square of theta, their sum equals 1. So here we have that is cosine square of theta, which is equal to right-hand side of this identity. So it is proved. Okay, question 5. Given that sine of theta is equal to 4 times cosine of theta, and the angle theta is between 0 and 90 degrees. Find the value of sine of theta times cosine of theta. Okay, so now from here, again, since theta is between 0 and 90, that means that both are acute angles. So by drawing our reference right angle triangle, suppose that this angle is theta. Okay, so if this angle is theta, let's say opposite side is A, adjacent side is B, and the hypotenuse is C. And using this one now, we can get this trigonometry ratio. What is sine of theta? That's equal to A over C. And how about cosine of theta? Cosine of theta is equal to B over C. And also using Pythagorean theorem, right? A squared plus B squared is equal to C squared. All right. So now that is the first, actually, the approach. The second part is, let's say this number 1, and change the color, and number 2. And using the given condition, sine of theta equals 4 times cosine of theta. What is sine of theta? That is A over C. And how about equals 4 times cosine of theta, that is B over C. Okay, now from here we'll get this relation between A and B. So A is equal to 4B. All right, so now either actually instead of A I can write 4B, or instead of B we can write A over 4. But again, if you just substitute into this Pythagorean theorem, here we have, what is A squared? A squared is 4B squared. And here we have B squared, that's equal to C squared. So from here, what is C? C is equal to 16 plus 1, it is 17. So that's equal to square root of 17 times B. So that is the value of C. And also using the similar thing, we can get actually we can express C in terms of A, because now here also actually C equals square root of 17 times B, or let me just write here, or C is equal to square root of 17 times, what is B? B equals A over 4, or that's equal to square root of 17 over 4 times A. Okay, so now you have to find the value of sine of theta times cosine of theta. So now sine of theta times cosine of theta. What is sine of theta? That's equal to A over C. A over C. Cosine of theta, that's equal to B over C. Equals, and here we have, let me just keep, okay. What is A? A is, or C, let's say. What is C? Here we have A over C is equal to square root of 17 over 4 times A in terms of A. And how about b over c? Here we have b. And how about c in terms of b? That is square root of 17 times b equals, so this a, they cancel each other. And also b, they cancel each other. This 4 goes up, right? 4 times 1. Here in the numerator, we have 4. How about the denominator? Square root of 17 times square root of 17. That's equal to 17. So the answer is, it is 4 over 17. Okay. Next question. Given that sine of 2 alpha equals cosine of 3 alpha, and alpha is between 0 inclusive and 72 not inclusive. Evaluate alpha without using a calculator. Okay. So now from here, we know that since solution, okay, since alpha is between 0 and 72, if you multiply by 2, here we have 2 times 0, it is 0. Okay. So here we have, I just multiply also by 2, 2 alpha less than 2 times 72. That's equal to 144 degrees. And how about if you multiply by 3? Here we have 0 less than or equal to 3 alpha less than 3 times 72. That's equal to 216 degrees. Okay. And since actually it says that sine of 2 alpha is cosine of 3 alpha, right? Actually, if you just draw 4 quadrants here, let's say this is our first quadrant, second quadrant, third, and fourth, right? The sine, actually sine function, the first quadrant, it is plus, it is plus. How about cosine function? Here it is plus, it is minus. And also third quadrant, actual cosine, it is minus. Here we have minus and plus. So on the left-hand side, sine of 2 alpha, it is between 0 and 144, it is plus. That means that also this cosine of 3 alpha, it must be positive. Otherwise, it doesn't make sense. On the left, we have positive value. On the right-hand side, we have a negative. So which means that actually for this thing to be positive, right, this 3 alpha must be between 0, maybe inclusive, and also less than or equal to, it is 90 degrees. Which means that actually we have to consider this question over this interval from 0 to alpha less than or equal to, it is 30 degrees. Okay, actually not 72. Actually, this alpha must be between 0 and 30 degrees. Okay, so now since it is so, that means the sine of 2 alpha, that is between 0 and 60, cosine of 3 alpha between 0 and 90. That means that both angles are acute angles. I mean, 2 alpha and 3 alpha, they are acute angles. And so that means that since this sine of 2 alpha is equal to cosine of 3 alpha, they are both actually acute, right? This implies that this 2 alpha plus 3 alpha should be equal to 90 degrees. That means that these two angles, they must be a complementary angles. Now from here, we can get what is alpha. Alpha is equal to 90 over 5. That's equal to 18 degrees. So if it is so, under this condition, this alpha must be equal to 18 degrees. Okay, next question, question 7. Given that theta is between 0 degree and 90 degrees, and 3 times cosine of theta squared minus 10 times sine of theta plus 5 equals 0. Find the value of cosine of theta. So we have to find the value of cosine of theta. Okay, again, here, since it's a quadratic equation, we have to solve this, okay? I will just, number one, we know that cosine squared of theta is equal to 1 minus sine square root of theta. Okay, and also suppose that actually W is equal to sine of theta. Just, I don't want to write this again and again. And after actually observing these two things, I'll just rewrite our equation. So here we have 3 times, what is cosine square root of theta? That is 1 minus W squared. Minus, here we have 10 times W plus 5, that's equal to 0. Now, if we expand this, here we have minus 3W squared minus 10W, and 3 plus 5, that's equal to 8. So that's equal to 8. And let me just keep the coefficient of this leading coefficient. Let's say this W squared positive. How? Multiply both sides by -1. So here we have 3W squared plus 10W minus 8 is equal to 0. So we have to factorize it. How can we factorize this? It is 6 and 4, right? So here we have 6 as 3W squared plus this 10W. I can write it as 6W plus 4W minus 8 is equal to 0. Now, if you just make a group, right, 2 groups here, the first group and the second group. In the first group, 3W is a common factor, W plus 2. In the second one, no, it doesn't work, right? Because it will be minus. So in this way, we cannot do that. So how about this 3W squared minus 12W plus 2W minus 8 is equal to 0. Or plus 12W and the minus, right? Now it works. 12W minus 2W, that's equal to 10. So from the first group, the 3W is a common factor, W plus 4. The second one, -2 is a common factor, W plus 4 equals 0. Okay, doesn't look nice. So let me just draw like this. So now if you just factorize this, what we have here is 3W minus 2, not plus, it is minus 2. That is minus 2 times, and here we have W plus 4. That's equal to 0. Now from the first part, W equals 2 over 3, or W equals -4, right? So actually we know that what is W? W is sine of theta. That means sine of theta is equal to 2 over 3, or sine of theta is equal to -4. And we know that the minimum, the smallest possible value of sine is -1. That's why this answer is, or root is, rejected. It's not acceptable. So our actual possible answer is this, or acceptable answer is this. In the question, it says we need to find the cosine, right? The value of cosine of theta. So immediately we can just draw our reference triangle. And let's say we are talking about this reference triangle. And suppose that this angle is theta. And what is sine of theta? It is 2 over 3. So opposite side is 2. And hypotenuse is 3. Now using Pythagoras theorem, right? 9 minus 2 is 5. We can identify or find the value of this side. That's equal to square root of 5. Now from here then dot cosine of theta is equal to square root of 5 over 3. Dashil, are you still having classes online?
Yes, sir.
So when are they going to open the schools in Philippines?
Probably this January, but I'm not sure.
This January, really? But usually new academic year starts when? In September?
Yes, sir. In September.
Hmm, I see. In Cambodia now, the government allowed to open all schools starting from tomorrow. So hopefully everybody will go to schools and universities tomorrow. And also even, actually they allowed everywhere to open. Now hopefully we're going, getting back to normal life here, starting from tomorrow. So maybe Philippines, I don't know. You may have still a lot of infected people, but here, Cambodia, Thailand, and Malaysia. But Malaysia not yet, but Thailand and Cambodia, they are step by step trying to get back to normal life. Yeah, Mr. Franz, I have a lot of friends from Philippines here. They cannot go back to Philippines because of the situation. And they are working here, but their families and kids, they are in Philippines. If they go back to Philippines, they may not be able to come back. That's what they are afraid of. We'll see. Okay, but hopefully it's getting better now, step by step. And I hope they will not close again. Mr. Franz. Okay, guys, let's continue. Question 8. It says let alpha, beta, and gamma be interior angles of a triangle. So that means that this alpha plus beta plus gamma, it should be equal to 180 degrees. If all of these equations, let me just highlight this, x squared, the first one, and this is the second one, and that is the third one. Are given three different quadratic equations whose coefficients are this tangent functions, tangent alpha, tangent beta, tangent gamma. Anyway, if all of this x squared times tangent of alpha plus 2x tangent of beta plus tangent of gamma equals 0, x squared tangent of beta plus 2x tangent of gamma plus tangent of alpha, and the x squared times tangent of gamma, 2x tangent of alpha, tangent of beta, have repeated roots for x. The repeated roots means that discriminant is equal to 0. Then determine the shape of the triangle. Okay, shape of the triangle, you know, how do you determine this? Is it a right angle triangle or acute angle triangle or obtuse angle triangle, right? By according to the angles, we have just three different possible cases. Number one is if all angles are between 0 and 90, that means that is acute angle triangle. If one of the interior angles is 90 degrees, then we call this right angle triangle. If one of the angles is obtuse angle, which is between 90 and 180, then it is called obtuse angle triangle. Okay. So actually, you see here, they're kind of symmetric equations. For example, if you just consider the first one, the first equation, what is its discriminant? Okay, let me just call this by delta 1. That's equal to b squared, that is 2 times tangent of beta squared, minus 4 times a, that is tangent of alpha, and times c, that is tangent of gamma. Since it has repeated roots, this should be equal to 0. Okay. Now from here, if you just simplify this, what we get here? Here we get tangent and the square beta is equal to 4 cancel each other. That's equal to tangent of alpha times tangent of gamma. Okay. Now similar thing for tangent of alpha squared will be equal to, from the second equation, tangent of beta times tangent of gamma. And for the third one, here we have tangent of gamma squared will be equal to tangent of alpha times tangent of beta. Okay, alpha, gamma, beta, gamma, and alpha and beta. Right now, from here, what do you understand? As you see here, if you just multiply the left hand side and right hand side, right, they will be the same thing. On the left hand side, tangent alpha squared, tangent beta squared, tangent gamma squared. On the right hand side, the same thing, tangent alpha squared, tangent beta squared, tangent gamma squared, right? So, and also from here we can see that So this tangent square root of beta equals tangent of alpha, tangent of gamma, right? From here, we know that actually this alpha, beta, gamma, none of them is equal to 90. Okay, from here, my first conclusion is actually this alpha, beta, or gamma. Okay, none of them is equal to 90 degrees. Okay, why is it so? Because we know that at 90 degrees, tangent is not defined. For example, let's say one of them is 90 degrees. Suppose beta equals 90 degrees. On the left hand side, we have something that's not defined, right? It is infinity actually. On the left hand side, alpha and gamma, it must be less than 90. So we have a number. It doesn't make sense. So for sure now I know that this triangle is not, what is it? A right angled triangle. That's my first observation. What is the second one? And suppose that one of the angles is greater than 90 degrees. Actually, if alpha, for example, let's say it is greater than 90 degrees, we know that if tangent of alpha, right, in the second quadrant, it is negative. So that means that now tangent of beta, it is positive. Tangent of gamma, if one is obtuse, others must be acute angles. Also this, what is it? Positive. And here we have negative. On the left hand side, I have something that's positive, and this one is negative, and this one is positive. So negative number, positive number equals negative number. Also, it doesn't make sense. That means that also I know that here we have alpha, beta, and gamma, that they are less than 90 degrees. They can, any of them cannot be greater than 90. Otherwise, this equation does not make sense. Okay. So now from here, what does it mean then? Actually, since all angles are less than 90 degrees, now we can actually write our conclusion. So the given triangle is an acute angled triangle. Okay, the given triangle is an acute angled triangle. Otherwise, it actually, one of the equations will not have repeated roots. Okay, that's it. Actually, when you look at the question, it may look scary, but a little bit thought may give us shorter solutions. Okay, and in part B, I think we have also 4 or 5 questions, I guess. Given the sine of theta times cosine of theta equals 15 over 34, and the angle theta is between 45 and 90, find the value of tangent of theta. Okay, now again, we already did similar question. So suppose that since angle theta is between 45 and 90, which means it is an acute angle triangle. And let's say this let it be our reference triangle. Okay, and suppose that this angle is theta. All right, now suppose that this side is A, and this side is B, and this side is C. Okay, now from here, what is sine of theta? That's equal to A over C, and the cosine of theta is equal to B over C. And also in the equation, what's given here? Actually, it's given that A over C times B over C, it is 15 over 34. And also we know that A squared plus B squared is equal to C squared. Okay, these are the given conditions. So using this one, we have to find tangent of theta. Of course, to find tangent of theta, I need to know A and B, okay? Or at least we need to find the ratio. Now from here, from the first part, actually, what is C squared? C squared equals, what is it? Something, right? If I know A plus B, A minus B, okay. C squared, that's equal to this. C squared. Okay, we need to find A over B. Okay, good. So now from this equation, this 8 over c times b over c equals 15 over 34, we can find ab or c squared. What is c squared? From there, c squared is equal to 34 over 15 times a times b, right? Because just take 34 and multiply both sides by 34 over 15 and also multiply both sides by c squared. That's equal to this. Now, if I substitute into the last equation, then here we have a squared plus b squared will be equal to 34ab over and 15. Okay, so now if you just multiply both sides by 15 and take 34ab to the left hand side, now we have this equation. Here we have 15a squared minus 34ab plus and 15, it is 15b squared. That's equal to 0. Okay, so now we have to solve this equation so that we can find its ratio. How can we do that? Actually, 15, 15. So in such a way that we have to factorize the 15, 15 doesn't work. How about 5a and 3a, right? It works, I think. Here we have 3b and 5b. This is minus, minus. If you cross multiply, minus 25ab minus 9ab, that's equal to, what is it? 34ab. So we can factorize it as 5a minus 3b times 3a minus 5b is equal to 0. Now from here, right, I can just find 5a minus 3b is equal to 0, or 3a minus 5b is equal to 0. Okay, so let me just change the color here. So now from here, dots, dots, dot, we need to find a over b, right? Because here, okay, what is tangent of theta? Tangent of theta is a over b. Actually, we are looking for this ratio. So a over b, that's equal to, from here, a over b is equal to, what is it? 3 over 5. Or a over b is equal to 5 over 3. So we have two possible answers. Then tangent of theta equals 3 over 5 or 5 over 3. Because they are symmetric, that's why we have two possible answers: sine of theta, cosine of theta, and they are symmetric. I mean, with respect to this, what is that? If you write a over c, b over times b over c, or b over c times a over c, it gives us the same result. That's why we have two possible answers. The values of tangent of theta will be 3 over 5 or 5 over 3. Okay. So given the sine of theta plus cosine of theta is equal to 2 times square root of 10 over 5, and theta is between 0 and 90, find the value of tangent of theta plus 1 over tangent of theta. Okay. Anyway, first observation is this. This tangent of theta, let me use green here. Tangent of theta plus 1 over tangent of theta, right? That is equal to, let me divide into two parts. Tangent of theta, that is sine of theta over cosine of theta. And this one is, what is it? Cosine of theta, because 1 over sine over cosine, cosine goes up, right? It is sine of theta. Now, if you bring into common denominator will be sine of theta times cosine of theta. In the numerator, we have sine squared of theta plus cosine squared of theta, which is equal to 1 over sine of theta times cosine of theta. So that means that if I know actually the value of sine of theta, cosine of theta, we can get its value. That's our first observation. The second one is, given the sine of theta plus cosine of theta, right? What happens if you just square both sides? Here we have sine of theta plus cosine of theta squared is equal to 2 times square root of 10 over 5 squared. On the left hand side, here we have sine square root of theta plus 2 times sine of theta times cosine of theta plus, it is plus cosine square root of theta equals, on the right hand side, here we have 4 times 10 over 5 squared, it is 25, and which is equal to 8 over 5, because highest common factor of 10 and 25 is 5, so we can just reduce this fraction by dividing both numerator and denominator by 5. This 8 over 5. Now if you just simplify the left hand side, we know the sine squared of theta plus cosine squared of theta is equal to 1, and take it to the left hand side, and here we have 2 times sine of theta times cosine of theta will be 8 over 5 minus 1, which is equal to 3 over 5. Okay, or if you just actually even, I can divide both sides by 2, it will be, what is it, 3 over 10. It will be, what is it, 1 over 2 times 8 over 5 minus 1, that's equal to 8, 3 over 10. So now then we can just write our solution, that here is equal to 1 over sine of theta cosine of theta, that is 3 over 10, which is equal to 10 over 3. So dot, 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 the result here is 10 over 3. Okay, let's continue. Question 3. Find the value of cosine of 15 degrees without using a calculator. Okay, last time I think we did for tangents, but now we need to find, what is it, cosine of 15. Okay, so how can we do that? Let me just draw one right angle triangle. Okay, look if it's okay. All right. Suppose that this angle is 15 degrees. Maybe it's not drawn to scale. At that time, this angle will be 705, and this angle is, what is it, 90 degrees. Okay, so we have to find cosine of 15. Cosine of 15 is adjacent side over hypotenuse. Okay, so suppose that this side is, I don't know, let's say this A. Okay, so now if I draw one actual side from here to this side, actually, anyway, here we have, we just draw something like this. All right. Anyway, let's say this angle is 15 also, and also this one is 15. So at the time, actually this side will be equal to this side. Okay, if it is 15 and 15, at the time this angle will be, it is 30 degrees. And how about this angle? That is 60 degrees. Okay, and suppose that this actual side actually is equal to I don't know. Okay, should I? Okay, first, okay, let's say this x and also this hypotenuse is x, right? And now from here, this is 30 degrees, right? What is sine of 30? Sine of 30 degrees is equal to opposite side over adjacent side. That is a over x. That's equal to 1 over 2. Now from here, what is x? X is equal to 2a. Okay. And how about cosine of actually 60? Cosine of 60 is equal to, let's say this side is y. Okay, it is adjacent sides. Actually, that is a over x. That's equal to, no, not the cosine. I think I need also sine. And sine of 60 degrees, that's equal to opposite side. It is y over hypotenuse, that is x. So that's equal to square root of 3 over 2. Now from here, dot, 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 also from here, dot, 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 y is equal to square root of 3 over 2 times x. But what is x? X is equal to 2a, right? From here, that's equal to a times square root of 3. Okay. So now we need to find cosine of 15. Okay, that's our first step. The next one, now we can answer this question now. What is cosine of 15 degrees? Sometimes writing on a tablet doesn't look so comfortable. Cosine of 15 degrees, right? In the right angle triangle. Let me just write here, this one is A, and this one is B, and this one is C. Right? It's a right angle triangle. That's equal to, what is it? Cosine of 15 adjacent side over hypotenuse. That is AC over AB, right? We know AC, right? What is AC? AC from here, let me just find it separately. AC is equal to x plus y. And what is x? X equals 2a. And how about y? Y equals a times square root of 3, or which is equal to a times 2 plus square root of 3. Okay. And how about AB? AB squared is equal to AC squared plus BC squared. That's equal to, what is AC squared? We have just found here, right? AC squared is, that is A squared times 2 plus square root of 3 squared. And how about BC squared? That is A squared. If you simplify this, that's equal to A squared. It is a common factor. Here we have 4. Here we have 4 plus 2 times 2 is 4 square root of 3 plus, here we have 3 plus 1, right? Which is equal to 4 is a common factor, 4a squared. What is that? Here we have 4 and the 4, right? 4 actually is out. So here we have 2 plus square root of 3. Okay. So now we can just substitute here then. So this cosine of 15 will be equal to, let me just write here, AC. AC is equal to, what is it? A times 2 plus square root of 3 over, and the AB. What is AB? Square root of this, right? Square root of this is equal to 2 times A times square root of 2 plus square root of 3. Which is equal to AA cancels each other. And also here we have in the numerator, right? Here we have square root of 2 plus square root of 3 over is equal to 2. So that is the value of cosine of 15 without using a calculator. Because 15 also kind of not very special, but it's also a special angle because half of the special angle, 30 degrees. Okay. Question 4. It says that in the figure, angle 1, we are given any triangle. I think we have no information is given here. In the figure, angle 1 equals angle 3. I mean, angle 2. Okay. And the angle 3 is equal to angle 4 prove that angle 5 is equal to angle 6. Okay. So now from here, okay, this angle 1, angle 2, angle 3, these are all interior angles of a triangle. Okay. Let me just write here like this. Angle 1, okay, plus angle 2, plus angle 3, plus angle 4, plus angle 5, plus angle 6. And their sum is equal to 180 degrees. Now from here, okay. Angle 1 equals angle 2. Okay. Angle 3, angle 4. 2, 2. Okay, this side is, let's say, A. This one is C, and this side is B. Just check if anything is missing. Question 4 in the figure, nothing. Proof. Mr. Deschamps, Mr. France, if you have any idea, let me know. Just trying to understand if everything is given correctly. Okay. Okay, and also actually here, suppose that this one is angle C. Okay, this one is angle A, and also this one is angle B. Okay, and also other relation, what we know here is angle C, okay, plus angle 1 plus angle 6, that's also 180 degrees. And the similar way, angle A plus angle 2 plus angle 3, also it is 180 degrees. And third one, angle B plus a small triangle, right? Angle 4 and 5. Angle 4 and angle 5, that's equal to 180 degrees. And also we know that actually angle A plus angle B plus angle C, what is it? It is a round angle that's equal to 360 degrees. So these are the information, what we know. Now from here, 1 plus 2 plus 3 plus 4, 5, 6, okay, that is 180. And A plus B plus C, okay, 160. Okay, 1 equals 2. 3 equals 4. 4. Okay. 5. All right, I think we don't get anything here. I don't know what should I do here. Okay, how about if you just use the sine rule for these three triangles? For the triangle AOB, right? First triangle AOB. Okay, so here we have, what is this? Sine of 1, sine of angle 1 over OB is equal to sine of angle 6 over OA, right? So they are equal. And how about triangle AOC? AOC, what is it? Angle 4, let's say sine of angle 4 over OC equals sine of angle 5 over OA. Okay, and the triangle BOC, BOC, sine of angle 2, sine of angle 2 over OB equals sine of angle 3 over OC. Okay, so now from here, from the first one, I can write sine of angle 1 to angle 6 equals OB OA. So here we have sine of angle 1 over sine of angle 6 is equal to OB over OA. Okay, so now angle 4 is equal to angle 3, right? So I can just write here sine of angle 4 equals angle 3 over, and the sine of angle 5, I don't know, that's equal to OC over OA. And from the last one, sine of angle 2, that's equal to angle 1. Let me just write here angle 1 over 3 is equal to angle 4. Sine of angle 3 again, that's equal to OB over OC. Okay, so here we have 1, 3, right? Actually, if you just multiply these two together, 3 is gone, we will have 1, 1, 1, 5. Okay, angle 1 and angle 5. Okay, good. If you multiply, actually, let me just name, actually, put number here. This is our first ratio. This one is second, actually, proportion. This one is the third one. Okay, let me just first multiply number 1 by number 2. What happens here? If you multiply number 1 by number 2, here we have sine of 1, sine of 6, right? And the sine of 3, sine of 5. So here we have sine of 1, okay? Let me just write here first, sine of 1, sine of 3, multiply or divides, sine of 3. Okay, I think I better divide, okay? Not multiplication, divide. Okay, if you divide it, so here we will have sine of angle 1 over sine of angle 6 multiply, because if you divide by this, we should just change the fraction upside down. Here we have sine of 5 over sine of 3. That's equal to OB over OA divided, that is times OA over OA over OC. And OA cancel each other. That's equal to OB over OC. Okay. And how about if you multiply 3 cancel each other, we have 1 and 5. Okay, here we have 1 over 3. 5, 3. 1 over 3. 1365. Okay. 1315. Mhm. 1 equals 2, 3 equals 4, 5 equals 6. Okay. Sine 1, sine 6, OB, OA, sine 3, sine 5, and 1 and 3. Okay. Okay. So sine 1, sine 6 is equal to OB, OC. Okay. And also, actually, if you, what is it? If I multiply, right, 1 and 5, okay. If you multiply 2 by 3. If you multiply here, we have sine of 3 over sine of 5. Sine of 3, change the marker color. Here we have sine of 3 over sine of 5 times sine of 1 over sine of 3. That's equal to 3 cancel each other. Here we have sine of angle 1 and sine of angle 5. On the right hand side, what we have here, OC over OA, that's equal times OB times OC, because we have multiplied. And OC cancel each other, that's equal to OB over OC. Now, if you just combine this, okay, here we have OB, OC, and OB, OC. That means that actually sine of this actually 5 and 6, 1 and 3, right? So 1 and 5, 1 and 3. 1, 6, 1, 5, 3. 4 equals 3. 1 equals 2. Four. OBOC, OBOC. On the left, we have angle 1 and angle 5. And here we have three. Why can I get? Okay, let's just have a look and let me see if everything is correct, and I will finish the class. Okay, 1, 2, 3, 4, 5, 6. Okay, it's 180 degrees. Okay, and from here, sine of 1 over OB, sine of 6 OA. Okay, sine of 4 OC, sine of 5 OA. Okay, sine of 2 OB, sine of 3 OC. Okay, so if you divide this, sine of 1, sine of 6, okay, sine of 1, sine of 6, sine of 5, sine of 3. And how about this one, sine of 3, sine of 6? Okay, I think we should actually sine of 1, sine of 6, and sine of 1, sine of 3. If you divide them, 1 is gone, sine of 3 is left. And also sine of 3 is left. I think we should divide 1 by 3. And after that, 2 by 3. And we can just cancel 1 from the equations, and we can find 3, and that will be equal. Okay. Anyway, That shall I will finish here. I mean, maybe at home you'll finish yourself. Here, if you divide 1 by 3, actually here we have sine 1 and sine 1. They cancel each other. In the equation, we have sine 6 and sine 3. Okay. And also, sine 1, okay, sine 1 is gone, sine 3, okay, sine 3, right? And now we have the second equation, and the result of this division, we have sine 3 and sine 5, right? Sine 6, sine 3, and sine 3, sine 5. Okay, if we just combine them, we will get, okay, let me do this quickly. Okay, let's finish this question and I will finish the class. Okay, use green. So 1 and 3, I want to cancel 1. Okay, so here we have, let me just divide number 1 by number 3. Okay, so here we have sine 1 over sine 6 divided, let me just multiply, it is sine of 3 over sine 1. That's equal to OB over OA divided or not multiplied. Here we have OC over OB. OB, they cancel each other. That's equal to OC over O. Actually, from here, let me just write the result of this one is sine 1, they cancel each other. Sine 3 is equal to, from here, OB cancel each other, OC over OA times, and here we have sine 6. And how about from 2? From 2, actually, the 2, right, it's just sine of 3. The sine of 3 is equal to OC over OA times sine of 5. Now, sine of 3, they are equal to each other. From here, OC over OA, OC over OA. This implies that sine of 5 is equal to sine of 6, which implies that here, angle 5 is equal to angle 6. Yeah, actually, they're taking a long time, but what can we do? We have question 5, part C, question 1, question 2, and the additional questions. Anyway, Dashel France, thank you very much for your time. Okay, guys, I wish you good luck in your studies. Let's see if I meet you again or not. Okay, have a nice weekend. Take care. Bye-bye. All right.
Goodbye and thank you, sir.
Thank you, Dashel. Bye-bye. Okay, France, thank you. Good luck.